All right, let's talk about an element that is, well, pretty much everything. It makes up 3/4 of the entire universe. It's the stuff that powers the stars, and it might just be what powers our future. We're talking about the simplest, and you could definitely argue the most important atom there is.
You know, it sounds like one of those big cosmic riddles, doesn't it? Think about it. The fiery heart of a star, the massive oceans that cover our own planet, and the fuel that could one day power our world. What on earth could possibly tie all of those things together?
The answer, believe it or not, is hydrogen. Yeah, number 1 in the periodic table. But don't let that simplicity fool you. It is, and I mean this without a doubt, one of the most critical substances in the entire cosmos.
Okay, so here's our game plan for getting to know this cosmic powerhouse. First, we'll dive into what makes it so incredibly simple. Then, we're going to tackle this weird paradox, how it can be everywhere and nowhere all at once. After that, we'll check out its surprising strength, meet a few of its famous chemical friends, and wrap it all up by asking the huge question, is hydrogen going to be the fuel of our future?
All right, first things first, let's get to know the absolute basics of the universe's number 1 atom.
I mean, it really doesn't get more basic than this. You've got one proton right in the middle and one little electron zipping around it. That's it. That's hydrogen. And what's wild is that if it loses that one electron, you're literally just left with a proton, a fundamental particle. No other element can do that.
But hey, simple doesn't mean boring. Hydrogen actually comes in 3 different versions, or isotopes. Think of them as different models of the same atom. They all have that one proton. That's what makes them hydrogen. The only difference is the neutrons. So you've got protium, that's the standard model, 0 neutrons. Add a neutron, you get deuterium, what people call heavy hydrogen. And if you add one more, you get tritium, which is the only radioactive one of the bunch.
Okay, now for a real head-scratcher. This is the part where hydrogen is somehow everywhere and nowhere at the exact same time. So let's unpack this little paradox.
So when you zoom out and look at the whole universe, hydrogen isn't just a big deal. It's basically the only deal. A whopping 75% of all the regular matter in the cosmos is hydrogen. Stars? Yep, they're giant balls of hydrogen. I mean, to put it another way, every other element on the periodic table combined doesn't even come close.
Okay, so it's the king of the cosmos. But what about right here, on Earth? Well, this is where it gets tricky. If you try to find pure hydrogen gas just floating around in our atmosphere, you're going to have a tough time. It's practically non-existent. Why? Because it's so incredibly light that Earth's gravity just can't hang on to it. It floats away.
And this is the solution to that paradox. See, while free hydrogen is super rare here, hydrogen that's bonded to other stuff, it's everywhere. It's locked up inside other molecules, and the most famous one, of course, is water. Once you start counting it that way, it's actually the 3rd most abundant element on Earth's surface. It was hiding in plain sight the whole time.
So we've seen that hydrogen rarely hangs out alone here on Earth. So what happens when it pairs up with itself? Well, when 2 hydrogen atoms get together, they form a molecule we call dihydrogen, or just H2. And this little team-up, well, it packs a serious punch.
Just look at this temperature. 4,000 Kelvin. I mean, that is ridiculously hot. We're talking hot enough to weld metals that are incredibly difficult to melt. And that's the heat you can get from something called an atomic hydrogen torch. So the question is, where in the world does all that crazy energy come from?
The secret is all in the bond, that little connection holding those 2 hydrogen atoms together. Turns out the bond between 2 hydrogen atoms is the strongest single bond between any 2 atoms of any element, period. So it takes a ton of energy to pull them apart, and when they snap back together, all of that energy gets released as pure, intense heat. You know, the source material explains this perfectly. The amount of energy it takes to break that bond, chemists have a fancy term for it, bond dissociation enthalpy, is the highest on record for a single bond. It's an absolute world champion in the world of chemistry. And that is the powerhouse behind that 4,000 Kelvin torch. Okay. So since it's so fundamental, hydrogen is kind of a social butterfly in the chemical world. It loves to combine with pretty much everything else, forming some of the most essential compounds for our world. Let's meet a couple of its most famous partners.
And of course, we have to start with the most famous one of all, good old H2O, water. You see, its molecule has this unique bent shape, which gives it a tiny electrical charge. We call that polar. And that polarity is precisely why water is known as the universal solvent. It can dissolve more things than any other liquid, which is, absolutely critical for life itself.
Hey, remember deuterium, that heavy hydrogen we talked about? Well, when it teams up with oxygen, you get something called heavy water, D2O. It looks and feels pretty much exactly like regular water, but its unique properties on a nuclear level make it absolutely vital for moderating the reactions inside some types of nuclear power plants.
Now, take a water molecule and just tack on one more oxygen atom. What do you get? Hydrogen peroxide, H2O2. We all know it from the brown bottle in the bathroom, but on a huge industrial scale, it's a really powerful and clean bleaching agent. And it's also used to treat wastewater, which helps us keep pollution under control.
So, let's recap. We've got an element that's super simple, incredibly abundant, and forms the basis for life itself. So, what's next? Well, that brings us to what might be its most exciting role yet.
And this just shows you the incredible range hydrogen has. I mean, it's a total workhorse in making metals, helping to get them pure. It's literally rocket fuel, the stuff that blasts us into space, and, looking forward, it's got this huge potential to be a clean, totally non-polluting source of energy.
And all this leads to a really cool idea called the hydrogen economy. Basically, it's a vision of the future where we use hydrogen as our main fuel source. And the best part? When you burn hydrogen, the only exhaust is water. That's it. No CO2, no nasty greenhouse gases. Now look, it's not a magic bullet. Figuring out how to produce it cleanly and store it safely, those are huge challenges we're still working on. But the vision itself for a cleaner world is pretty powerful. So, that leaves us with one last big thought to chew on. We started this whole thing by saying that this one simple atom built the entire universe. It literally created the stars. And so the question we're left with is this. After building the cosmos, could that very same simple element be the key to saving our own little planet? It's kind of an amazing thing to think about.